In this video, we're going to do two examples involving central angles and inscribed angles in a circle. So for example, remember, here's our circle. One example of an inscribed angle would be angle DAC, because all three, D, A, and C, lie on the circle. So that's inscribed. A central angle has the vertex, the center of the circle. So a central angle would be, for example, DOC. Angle DOC is a central angle. Now in this case, both of those angles intercept the same arc. It's this arc, this 30-degree arc from D to C. Okay, well, let's find the measures of these four angles. And I think the second and fourth one are the more simple than the other two. Let's do those first. What is the measure of angle COB? COB. Well, that one's very easy because we are given that this arc has a measure of 60 degrees. Well, what does that mean? The measure of this central angle is that intercepts the circle at C and B. This angle right here has measure 60 degrees. That's just by the definition. When you have a central angle, whatever the measure of that angle is, it's equal to the measure of the arc that it intercepts in the circle. So the measure of angle D, what did I start with? COB is 60. I'll put 60 degrees. And then number 4, same reasoning. What is the measure of angle DOC? That's a central angle, DOC. Since the arc is 30 degrees, the measure of that angle is going to be 30 degrees as well. I don't think it'll matter in this, but that means that 60 and 30 gives us 90. This is a right angle, DOB. Okay, now let's look at the measure of angle CAB. The measure of angle CAB, where is that? CAB. Well, that is not a central angle. That's an inscribed angle, CAB. And remember our theorem called I think we called it a lemma. I'm going to write it up here. Half arc measure lemma. Oops, lemma, 2 M's. Half arc measure lemma. The measure of angle CAB, that inscribed angle right here, is half of the measure of the central angle COB, where instead of having A as the vertex, which is on the circle, we have O, the vertex, which is the center of the circle. So the measure of angle CAB is equal to, let's see, 1/2 the measure of arc that it intercepts. Let's see, CB, measure of arc CB. And what is the measure of the arc CB? It's 60. So this will be 1/2 of 60, or 30 degrees. So the intercepted arcs are half the measure of the inscribed angles have measures 1/2 of the central angle. So here, same thing's going to happen for the same reason, half arc measure lemma. The measure of angle DAC, that is going to be the 1/2 the measure of the arc from the central angle, which is 30 degrees. The measure of this arc is 30 degrees, which means the central angle has 30 degrees. An inscribed angle, this angle right here, is going to be half of that, which is, so we've got 1/2 the measure of arc DC, which is 1/2 of, what do we get? Half of 30 degrees, which is 15 degrees, this angle here. Okay, so we've done those 4. Now we've got one more part to this. Find the measure of angle BAE in 2 different ways. One using arcs, one using properties of isosceles triangles. So let me complete that angle. I didn't draw it here. BAEA is the vertex. So here's the angle we're looking for. Notice that is not a central angle, but it is an inscribed angle, BAE. They're all points that fall on the circle. Okay, so let's use arcs first. All right, using arcs, how can we do this? Well, notice it is an inscribed, this BAE is an inscribed angle. Well, what is the central angle that intercepts at B and E? Central angle means the vertex is 0. So let's see what we know. Well, for one thing, if this is 20 degrees, what's this angle right here? What's BOE? Well, since this goes through the center of the circle, this is a straight line segment. So we know that it's going to be 180 degrees on kind of the flat angles. 120 would make this 160 degrees, which means that this arc has measure 160 degrees. Okay, well, this inscribed angle, BAE, what we're looking for, BAE intercepts the circle at EB. All right, and since it's an inscribed angle, it's going to have half the measure of the central angle that intercepts it at BE. So we're going to get the measure of angle BAE is equal to 1/2 of the measure of the central angle, or the intercepted arc, which is 160 degrees. So 1/2 of 160 equals 80 degrees. Okay, now the other method is going to be using isosceles triangle properties. Okay, so let's see. What we want to look at, where is the isosceles triangle that you think we might be interested in? Well, it looks like it'll be this right here. And notice that since OA and OE are both, each one is a radius of the same circle, that length and that length are exactly the same. So that's an isosceles triangle. So I'll write down the triangle that we're looking at is OAE. OAE. So OA, that length is equal to the length OE. So therefore, these two angles are equal to each other, the base angles of this isosceles triangle. So we could say that, let's see, 20 plus, these two are the same. Let me call it x. So we're looking for x. So that tells me that 2x, that's x plus 20, equals 180. So that means 2x equals, subtract 20, 160, and x equals 80 degrees, as we suspected. We already knew that from doing it over here. Okay, 2 different ways to determine the measure of angle BAE. Okay, the next final example for this video I've given you a circle, and I said I want you to inscribe a triangle ABC into it where the length AB is equal to AC. So that means we're going to have two sides of the triangle with equal length, so we're going to get an isosceles triangle. And make the measure of angle A less than 90. So what I did, I put A at the top of the circle. You did not have to do that. You could put it anywhere you wanted on the circle. And then what I did was started coming down like this. If you put B and C about right there and there, it would give you a 90-degree angle because that would be a triangle inscribed into a semicircle. So I came down even farther, and B and C are down here. So by the way I drew it, you know that that length and that length have to be equal to each other. AB is equal to AC. And you can obviously see that this is less than 90 degrees. Okay, now we need to draw a point P on this minor arc BC. I suggest you not draw it right in the middle, but make it either closer to B or closer to C. I'll put it about right there. That's the point P. Doesn't matter where you draw it, though. It will work if you put it right down in the middle. But I think it gives you a better view if you don't put it in the exact center of B and C down here. Okay, so we need to prove now that angle, or I should say ray PA, let me draw that. Ray PA that's ray PA, bisects angle BPC. All right, I guess I need to draw that angle as well. BP and P to C. Okay, my lines might be off a little bit, but we don't need to worry about that. All right, so what we're doing, proving that PA bisects this angle, BPC. Well, what does it mean to bisect an angle? It means basically you break it into two angles of equal measure. So we have to show that this angle is equal to this angle. And then we will be done. All right, let's go ahead. Notice that, let's see, I'm going to start off by saying that AB equals AC. Well, that's given, right? AB and AC have the same length. So that implies that, remember, two chords that are the same length intercept arcs of the same length as well. So that means that this arc has the same measure as this arc. So I could put maybe 2 notches there, 2 notches there to show that they have equal measures. So I'll write measure of arc AB equals the measure of arc AC. Like that. We said that in the previous measure. Congruent chords like this chord and this chord intercept arcs, this one and this one, of equal measure. All right, so then we could say that, let's say, APB, let's look at the measure of angle APB. Well, what is APB? It's an inscribed angle in the circle, because all 3 points APB are on the circle. And how do you find the measure of an inscribed angle? Well, it's 1/2 of this arc measurement. It's 1/2, oops, that's APB. APB is equal to 1/2 of the measure of the arc AB. I think we called that the inscribed angle theorem. or maybe the half-arc measure lemma. Okay, so we know that the measure of this angle is 1/2 the measure of this arc. But this arc has the same measure as this arc, so we can say that's equal to 1/2 the measure of AC, arc AC. Those two things are equal to each other, this and this. Okay, that's why are we doing that? By substitution, because we know the measure of AB arc is the same as the measure of arc AC. All right, 2 more lines, and I think we will be done with this. So what is the measure of angle APC? The measure of angle APC is 1/2 the measure of arc AC by definition. APC is an inscribed angle. This angle is going to be 1/2 of the measure of its intercepted arc. And we're actually done. We proved that the measures of these two angles are congruent, this one and this one. And therefore, I'll go ahead and write the conclusion. Therefore, since this is equal to this, we can say that PA, the ray, bisects angle BPC. That's again by the definition of an angle bisector. So we proved that these two angles are congruent. If these two angles are congruent, then this ray PA is the bisector of the angle BPC.